I've chosen quite an example from the book. This is on page 231, and it's problem number 17. And here's how it reads. Y double prime plus 2y prime plus y equals to x squared e to the minus x. Well, when we go to work out the complementary solution, our characteristic equation is m squared plus 2m plus 1 equals to 0. It factors as a perfect square, which means there's a repeated root. So in forming the complementary solution, we're going to have the complementary solution as c1 e to the minus x plus c2x e to the minus x. So again, when you have a repeated root, you start piling on powers of x. Alright, well, there's an issue there, because when we look for our particular solution, the right-hand side has x squared e to the minus x. It already has e to the minus x in there. So I'm going to this book calls it case 3, and he talks about it on the bottom of page 227. And it seems a little complicated, but here's how it goes. We literally take the this has degree 2 repeated roots, so there are 2 roots. And this is a second power of x. So we use 2 plus 2 to get 4, which means our particular solution is going to be a x to the 4th e to the minus x, but also its linearly independent derivatives. Now I'm going to elaborate on that in the next video. But I need to essentially tack on bx cubed e to the minus x. So let me erase this. I'm going to rewrite y particular. I'm going to talk a little bit more about that. I think I might have misspoke here. Our particular solution is going to end up being ax to the 4th plus bx cubed plus cx squared all times e to the minus x. So let me elaborate on this. Bottom of page 227, author calls it case 3. And we had 2 roots from this characteristic equation. That's what led to these 2 terms. That's 2. We have x squared times e to the minus x. E to the minus x appears here. 2 exponent of 2. So add 2 plus 2, those 2's together, we get 4. I need to look at the derivatives. I need to look at a particular solution that includes ax to the 4th e to the minus x and all its derivatives. Well, if you start taking the derivatives of ax to the 4th e to the minus x, you'll end up with those terms. You'll end up with x cubed terms and x squared terms and x terms and constant terms, all times e to the minus x. In other words, a 4th degree polynomial would include an x to the 4th, an x cubed, an x squared, an x, and a constant term. And I can exclude these 2 from my particular solution because they're included here in my complementary solution. And matter of fact, whatever I get here will give me a 0 on the left side. So I can exclude the e to the minus x and x e to the minus x, again, from my complementary solution, because those appear in the, I can exclude them from the particular solution because they appear in the complementary solution. Alright, so what we have is quite a mess, and I'm going to reorganize my particular solution this way. Y particular. I'm going to factor out the e to the minus x. So it's a x to the 4th plus bx cubed plus cx squared times e to the minus x. Okay, well, we have to take derivatives. So the first derivative, we have a product rule here. So the derivative of this parentheses is 4ax cubed plus 3bx squared plus 2cx times e to the minus x. And then we have minus e to the minus x times this term. Well, think about that. If this is minus e to the minus x times this parentheses, and that's minus y prime, isn't it? Y particular. Alright, so let me fix something here. I just noticed that I forgot to put my derivative mark. So this is y prime particular. And again, one more time, just make sure you saw what I did here. I took a pretty neat shortcut. This derivative is a product rule. I have to take the derivative of the parentheses, I get this mess, times e to the minus x, plus the derivative of e to the minus x is negative e to the minus x times that parentheses. Well, negative of this is going to be minus y particular. So that's kind of a nice shortcut there that's going to save us some writing, I believe. Alright, second derivative is, alright, again I have a periodic rule here, so I have 12ax squared plus 6bx plus 2c times e to the minus x. And then I've got the derivative of, I've got this derivative times the parentheses, so it's negative e to the minus x times this stuff. And then I also have minus y prime. I think I better just write that out because I don't want to try to get too clever and just blow it here. So this derivative is going to be negatives applied to all this. So it'll be minus 4a x cubed minus 3b x squared minus 2c x times e to the minus x. So it's derivative minus of e to the minus x is negative e to the minus x, so I distributed the negative sign through here. Alright, and then this derivative is minus y particular prime. There we go. So, anyway, I think I've reduced a little bit of the clutter there. Now then, so what in the world is y double prime plus 2y prime plus y? Alright, so y double prime plus 2y prime plus y particular equals to, alright, so don't know if I'm going to be able to fit all this very well. I tell you what, I'm going to, I'll try to fit it in here. Alright, so we have 12a x squared plus 6b x plus 2c e to the minus x and minus y particular prime, and then I have to fit this in, plus minus 4a x cubed minus 3b x squared minus 2c x e to the minus x, plus 2 times y prime. Okay, so that would be plus 8a x cubed plus 6b x squared plus 4cx plus 4cx e to the minus x minus 2y particular, and then plus y particular. Plus y particular. Alright, so, well, I hope that's correct, because I don't want to redo this video. Alright, so 2y particular prime was 8. Hope you don't mind me being a little extra careful here. Alright, so, and all this equals to, I didn't write it out yet, all equals to x squared e to the minus x. We could do a little simplifying, I'm sure, that we have these two combined together to make it a negative y particular. So let me go ahead and cross that out and cross that negative 2, so it's minus y particular. And then I need to fit this in, so I really am running out of room here, aren't I? Alright, so I'm going to write down a few things, do a little bit of erasing, and then we'll continue on with this problem. So hope you've been writing things down yourself. Okay, I'm going to walk you through what I did so you can be sure I didn't pull a fast one on you here. Alright, I took this parentheses times e to the minus x. Then we had minus y prime. Y prime was this parentheses times e to the minus x, so it's minus this stuff right here. And then we also were subtracting y particular, so that changed the sign, became a plus y particular. So that was this part here. And then we have this parentheses times e to the minus x. And then this parentheses times e to the minus x. And then minus y prime, y particular. And it was all equal to x squared e to the minus x. That was the q of x in our equation. And rather nicely here, the y particulars cancel. And let's see, does this, I don't know if anything else cancels. Possibly all this cancels. Let's see. We've got minus 8a x cubed. There's plus 8a x cubed. It's a good sign. Negative minus 3b is minus 6b plus 6b x squared. Minus 2cx minus 2cx, that's minus 4cx plus 4cx. So, wonderfully, these two cancel that one. And so now we're down to this expression equal to x squared e to the minus x. And I can divide off the e to the minus x. So let me do some erasing and I'll clean it up here. So when all the dust settles, we have this parentheses, 12a x squared plus 6bx plus 2c equals to x squared. And think of x squared as 1x squared plus 0x plus 0. So that means that 12a equals to 1, 6b equals to 0, 2c equals to 0. So all we have to worry about is a. A is equal to 1/12. Aha. So our particular solution would have been just 1/12 x squared e to the, no, x to the fourth. It was x to the fourth, right? Yeah, because a was the coefficient of x to the fourth. 1/12 x to the fourth e to the minus x. So now we can write our full solution, which is c1 e to the minus x plus c2 x e to the minus x plus 1/12 x to the fourth e to the minus x. And, well, moment of truth, let's check the answer on that. Number 17 is c1 e to the minus x, c2 x e to the minus x, and x to the fourth e to the minus x over 12. Got it right. So, as I like to say in a regular class, we restored the universal harmony. So, there you have it. That's a pretty grisly problem. Okay. Well, next we're going to talk about this linear independence of derivatives, what that means, and why we're kind of restricted. You notice we've only been dealing with powers of e, with polynomials and sines and cosines. And there's a few more we could throw in there. But I want to talk about that in the next video.